First of all, thank you very much to the Politecnico di Milano and to my friend, Marco, and to the others and to Sto for this invitation. I'm going to do an experiment tonight. I'm not sure of the audience, but I'm told that now master's courses are in English, and it's become a global university in its approach. So I'm not quite sure what Italian English sounds like, but I'm Scottish. And you'll get a very, very mild Scottish accent occasionally. The experiment is to give you two shows in one. The sounds that you will hear are those of my thoughts, what I'm thinking about today and thinking about tomorrow. And the visuals are what I did. In other words, in a way, it's my past. But because we are part of a history of architecture and a lineage, we have to learn from the past and we can't escape it. And it's part of our fundamental DNA as human beings and as artists and architects. So in many ways, it's the present is what I'm saying and the past is what you'll see. I'm not sure this is going to work, but I'm going to try. Part of the reason for this is that when you give lectures, one of the first things that people ask is, what's the title? So this time I took a phrase from a Nobel Prize-winning physicist who happens to be Scottish, Charles Wilson, and he invented the cloud chamber, and that's where we first saw radioactivity, which led to a whole new world as we know it today. And he said, Scotsmen, they are romantic, inventive, speculative individuals. And the bit that's not up there, they also have the mind of a chartered accountant. That's the person who deals with the money. And as a Scot, I have to say that's largely true. One of the prides I take in the work that we do is never, ever to exceed the budget, and usually to give a bonus back to the client. So many of these projects that you'll see, actually the client has saved millions and millions of pounds or euros. And that comes from the very first moments of thought. And it's a great pleasure to be able to say to a client, you had 60 million euros, well, it only came out at 52 million. They tend to like you. Now, I was asking Marco earlier, is cost and cost engineering, economics, taught as part of the syllabus in the Politecnico di Milano? Because it went absent in the United Kingdom about 40 years ago in schools of architecture and engineering. Cost is irrelevant, and that's actually a characteristic of most of the prizes that are given in the world of architecture today. Whether it's the Sterling Prize or the Pritzker, cost is never, ever an issue. Now, you try saying that to the Greeks today, or to most of the people who live on this planet. So every pound that we spend or waste, whether it's in over-designing structures or badly thought out thermal performance of a building, is actually wasting natural human resource. And in one of the texts that I wrote recently about systems in cities, is that every single person that's researching systems in cities, whether it's New York University, Imperial College, and no doubt Milan Politecnico, money is never seen as part of the system. We talk about infrastructure, energy, transport, all those things. But money is a system which can be changed and is fundamental to the way we operate. So this is my home in Paris. I don't have a permanent home in Paris anymore. And I was amazed by this picture. I just thought it was wonderful. It was the ultimate intelligent tramp. So I'm going to not randomly put slides through. There is a sort of sequel. If somebody thinks it's really, really interesting, the picture, then I'll stop talking about or reading what I've got to say, which is more philosophical, and talk about the picture. So it's kind of an accidental lecture, but the idea is to get two in one, twice your money's worth. Now, a romantic is usually associated in history with chivalry. That's the origin of the word. Now, a chivalrous person was trained to serve others. And that is the fundamental training of architecture, is to provide a service to others. And also the chivalrous person, the romantic, aspires to beauty. So it's beauty in the service of man. Now this particular architect in front of you, this romantic, Scott, actually likes poetry. And I write before I actually draw anything. And the reason is partly to do with a long, slow process of mastering my own language, English, but also recognizing that when you draw something, the image of the drawing can stay in your brain far longer than a few words. And the other advantage of words is you can move them around quite quickly. And I use words to investigate ideas. And if I'm lucky, I get a really nice poem. And if I get really, really lucky, I actually write an aphorism. An aphorism, for example, that I wrote about architecture. Architecture has two stages, the dream and the nightmare. The nightmare being reality. So you're all in the dream zone at the moment. So what comes out of this poetic side is that you're trying to describe what's around you and what's going on in your imagination. And its objective is to let what I call the unteachable spirit aspire to the unreachable. Because our spirit is not something you can teach, it's in you. And if you aspire to the unreachable, you'll end up with art. And as a little aside, I have a pet theory which I'll throw out because it's polemical, that there are only ever 4 stages in any story or any history or any event of significance. The first stage is you send out the spies. Now, in the old days, that was often the priests. And the aim was to capture the minds, to understand the minds of the people that you wanted to get hold of. The second stage was, having thought you've done that, and you've surveyed the territory, you send in the soldiers. And they capture the minds, the people, and they capture the territory. And then in comes commerce behind the soldiers to exploit the people and exploit the territory. And if they make a big enough profit, you get art. Now that is a Western appreciation of what we, as a, if you like, a nation of Europe, did for centuries. It's also the story of where we've got to in space. So it hasn't really fundamentally changed. In other parts of the world, there's difference, of course. So what is the speculative aspect is that I started in medicine and feared getting bored because it was like being at school again. And so there's been an aspect which is that I've speculated outside of the territory I'm supposed to behave in. So as an architect, I spent more time writing poetry and performing on stage at Liverpool when I studied in Liverpool than I did studying architecture. I accidentally went to Japan, lived there for nearly a year, came back and decided to do urban investigations into free time space at the planning school in London. And then accidentally I became an architect. So I'm not really tamed. So for those that know the story of the Little Prince and the fox, apprivoise-moi, I think is the French. Yeah, that's something which is very difficult for me to accept. So my enjoyment as an architect has been working alongside other people. Architecture is not done on your own, buildings are not done on your own, and the spirit of just working with others, whether they be artists or physicists, engineers, is a sheer delight. Particularly, and this is the joy I've got from those, is when their interests go beyond their own domain. So you sit at a table, you as an architect feel you have skills. They may be about synthesis in a particular moment. An engineer will have particular engineering skills. The poet might be able to read a better interpretation of the reality you're dealing with. The wonderful thing is, each of those people knows when to talk. But beyond that, they're interested in architecture, in the same way I'm interested in their poetry. The poet is interested in the engineer. Those are the really good people to get round the table. And I've been very privileged to have worked with an awful lot of very, very, very intelligent and nice people. So the message that I've given so far is don't waste money, don't waste energy, think clearly at the beginning, and you can save an awful lot of pain for a lot of other people later on. I put this slide up because it represents something which I don't quite understand. I can understand growth, and I can understand the maturity or the changing nature of a culture. What I can't understand is why lots of Europeans run off to China or to other countries to put up their ego trips. I don't quite understand it. Maybe I'm just on the wrong planet at the wrong time, I don't know. But it seems that they could be doing far more, not necessarily back home, but for the people who live like I do on that little grillage under a plastic tent somewhere on the planet. So I'm going to talk about innovation. This is my theme for this evening, because it's how we move forward from the status quo. The pictures, as I mentioned earlier, will be about the past, largely. So what is innovation? Well, it's not imitation. Imitation is the most marvelous business model. If you can imitate quicker than anybody else a good idea, you can make a lot of money. Since I'm not interested in money other than saving it for others, I don't do any imitation, which makes it very difficult for the architects in our studio in London, because architecture magazines are banned. They've never been in our office for over 30 years. The odd Frenchman will come in with one hidden under his arm or under his coat, but generally, architectural magazines convey images, not content. And that's part of the communications world that we've got today. So you're seeing plenty of images, plenty of surface, but the world has got very thin at that level. And I think that somewhere like the Milano Politecnico has the ability to look deeper into things, particularly in the field of architecture and urbanism. So when you saw that picture of Shanghai's developing skyscraper profile, you could look at it and say, is there any innovation there? No, there is none. And I'll tell you why, because developers don't do innovation. Promoters don't take risks. So what you're seeing is pure commerce. Now, if you're working in the commercial field, it makes it very difficult to innovate if you're an architect. Not that you have to innovate, but it makes it very, very difficult. And as I mentioned, it's because of the risk factor. And what happens when you get banks or developers going bust is because they've taken risks, they've overgeared, but they will never let the architect do it. Strange, because they need to, because ideas are the way you move forward properly. So a few years ago, when I sat in the one chair that architecture had at the European Construction Technology Platform in Brussels, I was looking at a situation where a group of Italian companies, there were 40 chairs there, 3 or 4 Italian companies got together with some Spanish companies, and they were going to turn us all into troglodytes, people who live underground. And this was the program that they were pushing quite hard on the back of 4 billion euros of research in the construction industry. And this is only a few years ago. Their argument was that since all the towns and cities of Europe are old, and all the centres are conservation areas, we can't possibly live overground anymore. So the people that dig tunnels and pour concrete wanted to get hold of this 4 billion euros of money. Well, we managed to stop them. And we have an energy program. And for those that are familiar with it, the big one is one of the big ones is a thing called E2B, which is energy to buildings, which has a budget of 1.5 billion euros, which you can team up with people and go after. So if we look at innovation and think, is it based on R&D, research and development? Not really. It is in part. If you look at the Japanese economy of the 80s, before they crashed, they spent over 3% of GDP on R&D, but it didn't deliver the level that they expected. And if you think of the Soviet Union, before the wall came down, so back in the 70s and 80s, their investment in R&D was higher than the USA in terms of per head of capita. Did that give them the economic strength? Nope. So you have to ask the question, what is it that enables companies to develop new products, new ideas, and bring to the marketplace? What is it that's missing? And what's missing is commitment. And that's at the company level. And if we don't find those new ideas and those innovations, Europe will keep going backwards. And humanity, I think, will also go that way. So what enables innovation to happen? So this is more of a political statement or an agenda for a political shift in Europe. We need to have markets. Now, I don't want to sound like Maggie Thatcher or Ronald Reagan, but if you have markets that allow, support, and exploit innovation, that's the first ingredient to having, if you like, a framework within which you can develop new ideas. Simply put, Europe doesn't create enough markets. The politicians don't get the message. They're very, very slow at it. And in a way, if we don't get the politicians to understand that without markets, then we are actually lost, because all the R&D, and there's billions of it going in, will actually go nowhere. It won't give us any answers. One of the areas where those markets could exist is public procurement. In other words, what governments are spending on infrastructure, buildings, and so on, should be part of that R&D project. Because as I've mentioned, the private sector in our world of construction rarely wants to see innovation. So if the public procurement doesn't allow it either, which is currently, I would say, the dominant ethos in Europe. If you look at any Oju advert for a competition, largely, largely the bigger companies tend to get most of them. That's because they don't want to take the risk. So if governments and politicians in cities are not taking risk, and the market of the commercial developers aren't taking risks, we aren't getting a chance. And the third element in this process of trying to create the ingredients for innovation in our society is the mobility of people. And by that I mean mobility in their heads. The Scots, 200 years ago, invented a lot of things that moved people, railways, and they built a lot of it around the world. We're actually beyond the point of moving people for the sake of moving people. What we need to do is move information coming out of people's brains, but also the brains themselves. I'm not sure that the knowledge society has yet reduced physical mobility to the extent it needs to in terms of an understanding about behaving slightly better on the planet. But I think it will come. And if we look at somewhere like Lima in Peru, the whole of Lima, and there's I think something like 15 million people in the conurbation, they're all able to access 4G already. You can't do it in London. So you think you're advanced, but we're not. So the speed of download, the speed of processing should enable this mobility of the brain or the mind to improve communications. If we think of the other aspect of mobility, if I wanted to live in Milan, could I transfer the mortgage, my borrowing on my house in London, to a property in Milan? No. The mortgage companies can't deal with it. Few insurance companies at that level can deal with it. So we think we've got an integrated Europe. We're a long way off. We dream at that level. And finally, I would say that I've grown up and seen the birth of the consumer society. Quite frightening. And in that, we have obviously a lot more people on the planet buying. But even at the level of a house mortgage in London, I can't transfer that to my son. I can't do a transgenerational transfer of a mortgage. Again, a fundamental failing in holding societies and communities together. So a lot of people think out there, when they're making a product, designing a product, they think about the consumer. I don't. The reason I don't is because this consumer is at the beginning of innovation. If I don't know what's happening today, yeah, I might as well ask a consumer, because they probably got a good idea. But very few consumers have a good idea of what's happening tomorrow, which is where we come in. So if you want to design for tomorrow, don't listen to the consumer. That's a big mistake. It's only the marketing people and the people who want to make money listen to the consumer. I hope I'm turning the pictures at the same time. No. And the fourth element in this framework for an innovation culture is risk. I come back to it. We actually need more entrepreneurial people. We need more business angels. And we need money, people with money, to take risks. Of those, the best people are still the venture capitalists, because they've made their money and they know that failure is very important in the process of being successful. That's the problem with politicians and governments. They can't afford to fail, so they don't take risks. That's the simple equation. Right now, I think we are seeing a European Union and our society in general in Europe produce and, in a way, dictate to us now a no-risk or a zero-risk environment. We see it in health and safety. We see it everywhere. So everything is controlled, and no one is responsible. The construction methodology that dominates the European market, particularly in England, is design and build. In other words, the architect thinks he might be able to detail the building the way he wants, but he won't be allowed to. Why? Because the client transfers the risk to the contractor. And in England, I can only count two main contractors that still actually make things, can actually build a concrete frame and clad a building. That's an extraordinary change in the 30 years I've been an architect. Because in those when I started and trained as an architect, you had a client, he hired an architect, and the architect got hold of a builder. If you look for a builder today in England, you won't find one. You'll find companies that call themselves main contractors. What they do is manage. They manage a process. They don't have the building skills. Those skills are all in the trade contractors, the specialists. So they are doing the management that an architect used to do by nature. But the architect today doesn't get much of a chance to manage, because he, the architect, is seen as the risk. Because most architects don't care about money. So you can see the cycle. So this management ethos also does very little to encourage innovation. It's a killer. So we now have a risk-free Europe. A Europe that doesn't want to take risks. So the only way I think you can shift it is by legislation. And in energy terms, I brought into the UK in 2006 the idea of zero carbon housing. And that included the occupants and their behavior. It was passed by the government, but the house builders got together and lobbied to stop it. But it got passed by Parliament. But they pushed it out 6 years. Last year, our Conservative government took away the human component, which is, of course, the great consumer. It's a complicated story, but it's a message. But the idea of legislation is not simply to produce zero carbon housing. It's to motivate the construction industry to invest in research and to invest properly in it. And unless we have that sort of legislation, I don't think people are that bothered. It's a very sad thing to say, but they're not particularly motivated. Now we get to the fun bit, I think. This is where it mixes up. So if we think there is a need to be creative, innovative, and proactive, legislation from government can help move things forward. That legislation can be morally right, have good ethics, and somehow suddenly doesn't appear as if they might lose their job by deciding to do it. So that's the mechanism I think, and I've found so far in the UK, is the one to push hard at. This little diagram is one that comes from a guy, a social anthropologist, Stanley Diamond, an American. He's dead now, but the idea of progress is that you've got these three components: social organization, ideology, and technology. If one of them goes out of sync with the other two, the wheel will turn, because we'll try to mend what we think is wrong with the world, whether it's ideological or social or technological. And that, in a way, is a simple wheel of progress. It's not that complicated. But if, for example, we're not moving on the technology and the ideology shifts, we have a real problem. And that's what's happened to some extent in Europe. We might say that the banking crisis, you know the word gangsters? Nods, yeah. Well, there's a very good word for bankers. They're called banksters. And they undermined our social organization because they took away trust. Now that's a particular type of banking, investment risk banking, but because in England and in America it was tied in with ordinary banking, it all kind of went pot. So this little diagram, I think, conveys a sense that if you look at the ideological one, the architect probably today thinks what he's designing is good. He'd like to think he was designing good things. Whether he knows it's good or bad, in front of other people who might criticize it, he wouldn't know, or she wouldn't know. So understanding what is good in our society is quite tricky. We think we're doing good. But how can we express it? And I think that we use metaphors in architecture a lot. And a metaphorical intelligence that gets, if you like, makes evident in the process of the building and what it looks like, will give a statement about what we believe our humanity is. And that, I think, is one of the key roles now in what we design. So in that, and if you look at the diagram, we have the architect, or the planner, acting as the classic mediator between commerce and culture. Those 3 and 4 steps of any story in the history of man. And that's where we lie. We lie between commerce and culture. We like to think we're probably in the cultural end, and the way that architecture is pervaded in the press and the media around the world, you think we're just a bunch of artists. And to some extent, that is becoming true in the education of architects in the United Kingdom. Their technical knowledge, their social knowledge is actually not very high. Their artistic creations, and doing anything with parametric modeling and playing fun with software, is actually kids in a sandpit stuff, to me. And that's quite a significant shift, because it places the architect at the same level as a filmmaker, potentially even a graphic designer. So when your client doesn't come to you as an architect, but goes to a graphic designer or a filmmaker to give him or her an image of a building, he will then take that to a builder. And the architect is bypassed. So that's what the fast image thin world is doing, and has, I would say, hit architecture between the eyes in the United Kingdom. So as society evolves, technology evolves, and ideologies shift. And I came out with a nice aphorism when I was thinking about this problem when the banks crashed, was that we now have the opportunity to share values rather than value shares. If that makes any sense to anyone. There was a very nice writer, thinker, called Wilhelm Flusser. He was Czech, Jewish philosopher. But he wrote a little book called Design, funnily enough, and in it there's a short essay. And the short essay is called The Factory. And what he meant by that was that as historians, or pre-historians even, when we look back at societies, all we're left with are bits of calcium and pots and bits and things. They're all the things that were made. So it's not so much Homo sapiens that we see, but it's Homo faber. And I think that was him being slightly witty. We, in this room, are a lot of Homo fabers. We want to make things. And it's incumbent on us to be very intelligent, more intelligent than you think you ought to be, about what we make, or what we decide not to make. You've probably all come across, as students certainly, mapping. It became a buzzword in the 1980s, 90s. This man here, Ian McHarg, a Scotsman, I apologize for that. He went to America. He's a landscape architect. He went to America in the 50s. And the conservation, the natural habitat, if you like, the Countryside Conservation Commission of America, hired him to look at how towns could expand, where to put roads, etc. He gave a demonstration project, and he said the first thing you look at is geology. You understand where the water is, where it flows to, and how the ground below what you can see behaves. And he produced all these plastic films as he came above ground through to the infrastructure. And it was the first, if you like, layered mapping that I ever saw. I was very struck by it. And in many ways, that imparted to me in the 60s, when I was a student, the value of ecology, but also of geology. And we have seen in the last 30 or 40 years the shift from the production of buildings for the sake of buildings to a point where design and our concern for the planet, the ecology, if you like, and the environment, is actually the same thing. Design used to be quite separate as a process. Now design, ecology, environment is actually one thing. So that, in a way, is the new paradigm. Now, you can see on the surface of things in magazines that you'll have seen in the 90s or the noughties, 20s, 2000. Landscape became very dominant as an ethos, if you like, an architectural landscape architecture, but architecture as landscape. That is fashion. It's not really addressing the real issues. And that's the problem of magazines and not thinking quite deeply enough. And so the search for a sort of an intelligent design, a new design methodology, if you like, based on whatever you want to call it, a sort of post-industrial reductivist to an eco-sensitive design, actually requires a lot of thinking, and it's not easy to do. And if the thinking is hard, you imagine how hard it is to then design and get it built with all the other ingredients that come in. The only way I've found that you can move on that is to collaborate with very good people in a very open way and to manage the process and for the architect to get back into a central role where he is the ultimate synthesizer of those things. So in very simple terms, what does innovation mean for an architect as against what I've been describing, innovation for society? As architects, we explore space and form, materials, techniques, and some of us social agendas. And I gather this was quite a little place here for a bit of a revolution in the 1960s. So that social agenda hopefully is still alive. We also get involved with construction and assembly methods, and even the forms of contract and the management of the process. But to innovate, the first ever move you have to understand, and I was referring back to McHarg, you have to understand the context. Now, that is the first investigation of architecture. Most people talk about context as being an urban reference point, a historical, a conservation issue. I'm talking about the broader one, the ideology you're working in within, the society, the technology, the economic model, all of those, and what's going on in your brain at that particular moment as you switch off the heavy metal or whatever you're listening to. That is also relevant at that moment. That is the context. And you, and if you like, me, that's where I believe the real strength and the really good new ideas come from. It's that first investigation of context in a broad sense. I cheat because I use writing, because I maybe don't draw as well as I used to. I don't know. But I now write, as I mentioned earlier, to investigate context. Until I'm happy I've understood it, I don't move on the idea of designing a building. What happens also is that you investigate memory. You can't help it. We're human beings. And in that process of investigating memory, emotion comes. Now, I believe emotion comes from the inside and sensation from the outside. I know there are some senses in our body that work from the inside, but fundamentally, we are sensual, haptic, primarily optic animals, ocular animals. All those sensations that hit us are part of that context. They transfer into the brain, and our brains start thinking. And they get muddled up because memory comes in. And memory is often misguided, a little bit like the comedian in the adventure. So having analyzed the context, it's impossible to have a white piece of paper in front of you. The blank sheet on which you will now design cannot possibly exist. You have it, it's sitting there all over it. You may not have sharpened it up, it's got fuzzy edges, but all of that context enables you then to design properly. So I think if somebody said to me, here's a blank sheet of paper, design something, I would be paralyzed. I wouldn't be able to move. So I hope I've communicated that the context is not just physical, it's intellectual, moral, sensual. So moving into the field that we've got past society, we've had a look at us as architects. So how does industrial innovation happen? The next stage. If we consider material and technique, from these come all possible forms and spaces. And it was interesting, last week I was at Liverpool University where I'm a visiting professor, and they, for their third year students, for the very first time, have simply said, a bit like the Little Prince, design me a crematorium, but you can only use one material. So these students don't start with forms of crematoria or looking at Gunnar Aspland's wonderful crematoria and so on. They have either a brick, piece of concrete, piece of copper, or whatever. And that they have to understand. And that as you'll see in a minute, comes down to what I call the molecular understanding of material. So when we come to these softwares today, and you won't see any on here, you won't see any nonsensical software applications, but because we can do anything virtually today with software, and the software language is common throughout the planet, it means that we can communicate easily, relatively, with contractors, engineers, poets, whoever we want. So that barrier of language through software, we have to embrace it and look at software differently from what we have done up until now. And I think the other thing is that many architects today are very immature in their knowledge of materials. So they produce the sensual, visually sensual, lovely free-flowing forms and say, make it in glass to somebody over there, without knowing how to do it. They haven't got a clue. They don't know whether you can form it in 3 dimensions, whether you can laminate, toughen, meet the DIN standards. Engineer. My responsibility has gone with the picture. The engineer gets it and goes, merde. What am I going to do with this? So he tries to analyze it and put it together as drawings, make some maquettes, get the architect to come and have a look, and they'll go, yeah. And then what does he do? Whoop, to the trade contractor who's got to make it. The trade contractor looks at it and he says, better go and have a word with, I don't know, SIV or Pilkington or somebody and work this one out. And then they look at it and they go, how are we going to make the joints work? Oh, let's ring up Dupont. So, and eventually somebody down the line has responsibility for this thing that you're going to make. And the liability comes with insurance. Can you get in anywhere in the world, particularly in London, which is the center of world insurance, integrated project assurance? No, doesn't exist. And if you look at the new methodologies that are being promoted, I don't know if you're familiar with building information modeling, I'm sure you are, BIM. Well, that's the new religion. And we all worship at the BIM altar. And the reason we're all worshipping at the BIM altar is because contractors are being told, certainly in England, and it will come elsewhere, you cannot have a government contract unless you use BIM. So you talk to the contractor, and you explain that for 30 to 40 years, you've walked around the planet, you've drawn, you've modeled in 3 dimensions, and you've just discovered it. Right, really interesting. So all your models, all you're doing is attaching information to a 3D model that we all use, whether it's an Excel spreadsheet, some schedule, a detail. It's all pretty basic. But the tragedy is that unless you integrate now with the contractor really, really, really early, you won't get the work. Because the contractor has the money. He has more money than you get, 10 times as much, usually. That's if you get 10% fee. 20 times if you're only getting 5%. So all the power is now with the contractor. But who owns the model? Who owns the idea? You, the architect, maybe with some friends, a poet or a geographer, have come up with an idea which you've drawn as a 3D model. At a certain moment, you pass it to the contractor. He owns it. Does he? What about the intellectual property that you had? And then the contractor and eventually the client gets the BIM model, and it's his 3-dimensional information system for managing the building into the future. He can find every decision that was ever made and where to get every replacement. It's his management tool. So he now owns the BIM model. I will guarantee that in the first wave, in the next 5 years, you'll see contractors developing a BIM model of a very clever idea by an architect or an engineer, and they'll sell it. They won't just use it for one building. And they'll have the power game. Anyway, I mentioned that as an aside. But that's something that's very live at the moment. So how often have architects been able to begin to instigate innovation in industry, the industrial application of ideas. Pretty rare. We're not trained to do it. You can have wonderful R&D programs, research programs at universities, and you can link in with funding from industry. But again, the actual ideas, the application, is very, very hard for an architect to convince an industrialist this is what you should do. An engineer has a little bit better chance, but the really good ideas can come from the poetic end, and it's something I think architects have forgotten. And in Italy, you're lucky, because the architect engineer gets a diploma engineer. It's a kind of almost like a badge. German-speaking countries, it's the same. UK, America, we get a diploma in architecture. So we have design apartheid built into our system. The engineer is over there, which is why probably we got a lot of good engineers in the UK, but it also means that we don't work together naturally. Despite the myth that in England there's been a generation of architects and engineers working together, there are very few of us. There's maybe half a dozen that actually know how to do it. So the architect has to be more, if you like, more of an architect coming from the Anglo-Saxon world in order to achieve the sort of collaboration I think is needed. If you do architecture, engineering, and let's say Mandarin, I don't know if you have second subjects, but Mandarin might be one of them. That Mandarin may prove to be more important than your education of knowledge in the engineering or the architecture, simply because of the ideas it opens up for you through that language. This is very dangerous territory. I put in a couple of slides to do with Romans rather than Milanese, but Italy nevertheless. I'm sure everybody in the room knows, but I didn't until quite recently, that there's no reinforcement in the dome of the Pantheon. There's no reinforcement bars. That means somebody worked very hard to work out how to build a dome with sand and cement, basically. It's very, very clever. And Vitruvius, which you all know as the wonderful bit about his triangle of beauty, sturdiness, and constructability, he invented, of course, the waterproof concrete, the mixes. He used the pulvis putiolanus, ground up with cement, and that gave the Roman Empire the ability to build structures with foundations under the sea and in water. That bit of research actually gave Rome an empire, which is quite interesting. It's not just boats and planes and military. It can come down to pretty basic stuff. And then, of course, the Romans also started developing all those, apart from the mortars, all those wonderful shaped bricks to build columns and so on. And we go there as tourists to look at these things. But most people only look and don't see some of the secrets that are hidden in it all. Now I'm going to talk about modern architecture. It started in 1140. Now that's a dangerous thing to say. But I noticed in the room over there, one of the workrooms, there's a wonderful reproduction of Guernica by Picasso. And I think Guernica was 1937, and that defined the Reina Sofia Museum of Modern Art as 1937. So modern art, 1937. Anyway, my interpretation of modern architecture was somebody going away from the masonry simply holding up everything. In other words, the Abbé Sugar actually went about and said, there must be a nicer way of bringing light into this church. I want to try. So he worked up ideas of building. Lots of stuff got built and then fell down till he effectively got the Gothic arch. And that took away all the masonry and allowed air and light and eventually glass to stop the rain coming in. And then the glass tells stories. So suddenly the church changed completely. And why I call it modern architecture is because Abbé Sugar, Opus Modernum was the work, as he called it, and that means now. It's actually modern, contemporary. And in the industrial sector, staying on the industry, if we look at the engineers like Eiffel, Freycinet, Candela, Nervi, Otto, I'd even dare say Calatrava today, although I do question some of the things he does. These are the engineers that actually led the way in new materials, not the architects. The architects haven't got a clue. And it's a bit like now, if I said to you, what's the latest in, I don't know, filament technology? You wouldn't be sure what I was even asking, probably, most of you. Now, I just want to show one exception to the engineers. And it's a biased picture because it comes from Liverpool. And it's 2 buildings in Liverpool, I think. No, 1 building I'm showing. Oriel Chambers. There's another one in Wood Street. These were 1864. And they are curtain walling. What was interesting in this is that at the time of the American Civil War, this is a sort of odd world we live in, Mr. Root of Burnham and Root, famous Chicago architects that started high-rise buildings, Mr. Root came to Liverpool. He was 13 years old. And that's because Georgia, where his father was living, was under siege. And it was to save his son. He sent him by ship to Liverpool. Now, Mr. Root also had a business, import-export, in the docks. Mr. Root ended up working for Mr. Ellis. Now, that's quite, for me, fascinating. I think for those that in the room are looking for a PhD subject, I think you look at The Origin of High-Rise and Mr. Ellis. And there's a lovely story in there. Nobody's actually written it. But what did Mr. Root went and do in Chicago was the first, as I mentioned, the first high-rise. So we've got Mr. Sugar and we've got Mr. Ellis a few hundred years later demonstrating that we're now in the world of the frame and the infill. And can the architect get into the industry again? Can the industrial innovation take place? A few years back, 20 years ago, I worked with Peter Rice and a guy called Lynn, a girl called Lynn, on spiders' webs. And this was just a desire to understand the strength, if you like, of the proteins in spiders' webs. You know, they're 7 times the tensile strength of steel for the equivalence area in section. And there's a very wonderful pavilion in Glasgow called the Kibble Palace. It was actually built for his house, but it was moved to the park many years later, which is the most beautiful dome and expresses, as near as I've seen in any structure, the spider's web. And if I said to you, well, I just have to say it's true, that these bars coming through here are only 2 centimeters deep. And it's quite a big span. But in that 2 centimeters, periodically, there's a hole. You see them 1, 2, 3. And all it is, it's almost like a bit of string. But it's a bit of wire, rod, that goes through all those. So the thing cannot collapse. It's held geometrically. And you'd wonder about asymmetric load, wind on one side or snow, and would it kind of collapse? Nope, it's still there. And that, if I was to say, to compare that with, let's say, I'll be very naughty here, a roof covering of the Athens Olympic Stadium by Calatrava, where you put a beam and a roof, that weighs 800 kilograms a square meter, heading towards a ton a square meter. The Bird's Nest Stadium in Beijing weighs 500, half a ton per square meter. And somebody from Zaha's office is coming, I think. Her swimming pool in London is 1/4 of a ton a square meter. The heaviest roof I've ever built is 48 kilos a square meter. That's what I mean about material, innovation. And you might say, well, it was the image mattered more, because Beijing, it was commercializing China to the rest of the world. You need an image. There are some other images you can make, very beautiful, with very little material, that can be sensational. So if we move on to fabrics, and this is where industrial innovation might happen, this is the history, and the Italians were brilliant at it, Ferrari and others, for decades. This is PVC. Now, PVC is improved, it can be recycled, but it's non-structural. And by that, it's not permanent. So it has very big limitations. At La Villette, we did a roof, but because we were about to use tetrafluoroethylene, which is PTFE, coated onto glass mat, the French said, you're hired to innovate for the French, to bring an industry to a world leader. So we cannot have OCF's worldwide renowned PTFE with its worldwide patents. So I suggested taking one F off, symbolic F, which gives you trifluoroethylene, which is a film, and you can cold laminate that onto a glass mat. Now, this is a long time ago for me, but it's significant in as much that as an architect, I rang up Solvay in Belgium, who I found out made this material. They mentioned somebody who put together Zodiac boats somewhere in France, whose brother was running the Brochet Aerospatiale in Lyon, who were making balloons to go in the Venus atmosphere. And suddenly you had all the technology you needed to produce a new product. My role was to write the specification, the key one of which was to have a structural fabric, in other words permanent, but let enough light through for grass to grow in Europe. Basically, Europe above Lyon. So it's 50% light transmittance. And it happened. These are common images. Again, technology, ETFE, ethylene tetrafluoroethylene. The first time that was used, despite what people might think in the world of architecture, was here. Arnhem Zoo, 1978, over the Alligator Park. Its great advantage, it's light. Is it permanent? Up to a point. You need air as a pressure system, so it's energy consuming to maintain its position. Its wonderful, wonderful lightness has one drawback. It's like a drum kit. So if you do like Mr. Grimshaw did at Eden, he used a space frame by Miro, and they put ETFE as pillows in it. And you're standing in the desert dome. Now, it doesn't rain very often in the desert. And I was standing there thinking about giving it an award or not, and it rained. So I had the sensation of rain drumming above my head in a desert. It didn't make a lot of sense to me at that particular moment. In the tropical dome, not a problem. So, moving on. You're very patient. The more recent materials in fabrics are things like the polymers like Kevlar. Now, a lot of those are developed as high-performance materials for non-architecture. This is sort of racing machines that go around the oceans, boats and sails. And of course, these new filaments, carbon as well, boron is another one, are being slowly introduced into concrete, slowly introduced into other materials to make them have better tensile performance. This particular exhibition that we did in a gasometer in Oberhausen was a story of water on the planet. It was called Blue Gold, and this was on the basis that the 21st century, in my thinking, would be the century about water. Those that don't have it, those that get it with great difficulty. And of course, the melting of the Arctic and the potentially melting of the Antarctic and sea rise. And we built a 50-meter high dome, this cone, and we slightly froze it so that ice slipped down and then it went through the floor, and the water was supposed to drip on resistance wire, very large scale resistance wire, so it would go psh, psh, and frighten people. So it was a kind of metaphorical statement about melting glaciers, man being clever with his big dome, but actually he was in trouble underneath, but you couldn't see it. This was a bit of a sad story. It was a nice story till it went wrong. And it went wrong because although the product, which you can see in the bottom right-hand image, is made from stainless steel wire and fiber optics, and the fiber optics, there are about 40 fiber optics in each 2mm diameter sheath. Actually getting to knit this on a loom, on a machine, was very difficult because the fiber optics are actually in the long direction, which is the warp in English, and the stainless steel wire is threaded in the weft direction. Holding the fiber optics in the sheath, the megalon sheath, is actually quite difficult to keep the tension whilst you're knitting. Anyway, we managed to make this fabric, and we won this competition with this idea for a monument to light for the turn of the millennium in Milano. And it was run by AEM, which obviously is an electricity company. And I don't know whether they put out 2 guys to give us a real problem or just 2 people who didn't have anything to do. But the first thing that happened was that the Arab, our engineers, were pushed sideways and off the job. And then not too distant, we were pushed sideways off the job. And it didn't get built as it was designed. And I think Mr. Scarby came up and said, "What's that doing in front of the railway station?" after about 18 months. So it's a very nice feeling that as an architect, I enjoy the company of people like Richard Serra and a few others, Rachel Whiteread, as artists, architects, sculptors who've had work taken away or destroyed. So, but it was very interesting in terms of the development, because the light unit that transmitted the colors was a very rough and ready, almost a garage product out of England. And AEM were convinced that a lighting firm in Turin could make a really nice one. Well, I have to say that when I saw the Italian one, it was very beautiful to look at. And when you switched the light on, the colors were so pale, it wasn't worth making the lamp. And that was a bit of the tragedy. So these are little exercises in industrial innovation as an architect. This building in Plymouth is woven phosphor bronze wire. Now getting the diameter of the wire right is quite important in the weave. And also, could we clad a building in a cloth, a metal cloth, that didn't stop the rain coming in, but could still work as a cladding? And could we use, as a result, only 10% of copper that we would use if we used a sheet of copper 3 millimeters thick? So the weight of this cladding is only 1/10 the weight of a copper-clad building, traditionally in sheet metal, 3 mil thick. And you can see it's near Plymouth and it's by the sea. And the sea and the winds come horizontal. So what lies behind this fabric, this phosphor bronze, is a geotextile. It's like the thing you use in earth retention. And as the rain and the winds hit, it makes a mist behind, makes it very microscopic. And of course, the geotextile collects it all, and it tumbles down and is collected around the bottom. The nice thing is, it's a public walkway around the edge, and you can touch the building. Now, there aren't many buildings you can touch that give. Actually look sexy, feel sensual, and you can touch it and think, nice. Yeah? We all know what that feels like. Okay. The other thing that happens, so we've changed, if you like, from being a visual to a much more sensual piece of architecture simply through the material. The next thing that happens is that the birds, the seagulls, you know the sea, they have guano when they shit. And the guano lands on the phosphor bronze. And in guano, depending what meal they've had at sea, you can get fluorescent colors, golds and yellows and greens. And the client, it's a theatre client, fortunately, we've asked him never to clean them. These were very early photos. So you get a Jackson Pollock painting in the making. And they will never clean them. But to do that, develop that product, was not as difficult as we thought. But it took a client who said, I'll risk it because it's like theatre, it's like a curtain. So he could understand it straight away. He didn't necessarily buy into the 10% of copper compared to a normal building, or the long-term, if you like, behavior of it as it darkens and becomes this canvas for seagulls to paint on. But the industry was challenged by it. They loved it, and it's available. What is interesting is nobody seems to know how to use it, which is extraordinary, since it costs very little as a cladding. At another level of industry, when I was growing up, there was a physicist at Imperial College, Dennis Gabor, who was investigating X-rays. And that X-ray research led to laser research. In other words, the two-dimensional control of light, if you like. Today, our society can't function without lasers. And I had an idea with this friend, artist friend Jean-Louis Lermite, that we would make three-dimensional light forms and move them around. In other words, we can make balls or rings of light and try and move them. I couldn't answer the government at the time when we were asking for the money, what was the purpose, other than give good reasons why people might get interested from a physics point of view. The result was that the EDF in France funded the research for us. And we managed to produce, as you can see behind me, some rings, somewhere, these rings, and sort of birds flying. And they went up and down this vacuum, which was about 0.5 millibar of pressure. I still don't know why we did it, but we did. And fortunately, there was a very famous Pink Floyd album out at the time called The Dark Side of the Moon. So I talked about tomatoes growing on the dark side of the moon, because you could go and get these balls of light and bring them through what is a vacuum of space. And then more recently, which is much more in tune with the kind of Italian architects training, design training, product design, we set out to make a new task lamp that would use no more than 10 watts, but could give 1500 lux. And we could change the color temperature, so you could have a candle, feeling of a candlelight, the warm yellow, at about 1 lux, 1 candela, literally, if you felt like that in the evening, or if you want to look at the accounts of how your company's doing, you could do that at full volume of light. That took 3 years to develop that lamp. And the most difficult part wasn't the LEDs, it was actually the hinge. This is the first sketch. That hinge, to allow it to go from anywhere, up the top there, to any position, and be very stable. And it came from a laptop hinge. And I wonder how many of you have actually looked at the hinge on your laptop of the cover. They're very nice little pieces of hinge making. Well, one of the firms that makes most of them is a Dutch firm, but our weight is much higher than a laptop lid. So we developed it, and that took quite a while. And I showed this really for this Arena Sophia Museum or not, for 2 reasons. One, it was the first time we tried to avoid doing any drawings before making something. And the bit that we tried to do it with is this, the dolphin fixing, that is the arm that suspends the glass. And the idea was we would draw something freehand that we actually liked. We'd scan it, digitize it, put it on a CD, straight to a CNC cutting machine, made. No drawings, other than the sketch. And that was back in 1990. And suddenly we thought a way of getting into industry directly, because you could give them the disc and nobody had to worry other than put the metal there. I've been told by Marco Imperadori that this is known as a Gmp building. If I showed you in my little book what the Gmp building would have looked like, it would have had straight sides and a shed like that on the top, something that's actually impossible to detail and make. We were brought in by Volkwin Marg to rethink how to do it, because his youngsters in their Aachen office were not happy with what they had designed. Their engineer, a very good engineer called Stefan Poloni, based in Cologne, he had done all the detailing, all the construction drawings of the steelwork for this scheme. And I gave a lecture in Cologne, went out to Aachen, and they asked me to look at it. And I have to say, what they had designed was a turkey. That's a derogative phrase. And the detail between their roof and the vertical, they had the structure on the inside of the vertical and on the outside, no, sorry, wrong way around, inside of the roof and on the outside of the vertical. Their joint where they met and the movements, and it's a very big building, had more problems, I think, than I've got on any building I've ever designed. They had to get one detail. So I said, no, I'm not interested. 3 months later, I met Marg in Hamburg, and I came with 2 arcs. And I said, for the same floor area, you can take 30% of your cladding away and still have the drama. And it would be easier to make. The only problem he had was that they were late on the building site, and the engineer had done all his work. So he asked me if I'd ever been an archbishop, and would I go down and placate the engineer. And that was fun. And we completely transformed and came up with this concept, which is very, very simple, which is a grid shell, which is 3.2 meters squares, no diagonals, because that disturbs the visual, takes away the sky. So you have to have good moment connections. And then hang the glass underneath. And the result is that it looks much more filigree. If you'd had the structure inside, it would look heavy and full up. And that's a barrel vault, basically. And we all know what barrel vaults do. We all know when the wind blows, they do that. So you normally have a wall at the end that stops it doing it. I didn't want a wall at the end that held up the grid shell, because if you can imagine that wall there, if it's connected to the grid shell, just here, up there, all the forces on that wall, and it's 5,000 square meters, get transferred into the grid shell. The grid shell changes. Concept destroyed. So the end walls are vertical cantilevers. They go up 30 meters. And they move under wind load. Oops, sorry. They do this. Inside the grid shell, inside the glass. And yet there's a nice elastomeric seal so it can move. And then the other thing that's quite interesting, I think, is you can see these bridges just about. There's a bridge there going in. The bridges are at right angles to this shell. Now the shell, you talk to a normal structural engineer, he will say 250 meters long building, steelwork, 2 expansion joints, please. I said, no expansion joints. Destroys the grid shell. But you have to have an answer. And I said, if we fix the building in the middle and we have bridge bearings where it lands, the whole building can breathe along its length. And it does, up to 60 millimeters each end. So when you go through it at right angles, it could hit. Oh. So again, you just allow a movement joint. We had 4 months to design it, technically detail it, to tender, and 2 firms in a joint venture got the job. Miro with Zähler, or Zähler, Glasbau Zähler. And their immediate request was to the client, can we carry on working with Ian Ritchie? Now, most clients will say, no, he stays with me. But this client was intelligent. And we said, we work from London with the industry now to make sure it gets built. And our guy who's been working with me on it goes to Leipzig and holds the hand of the client. And in 2 hours at Frankfurt Airport, the new contracts were done. And that enabled everybody to have fun and end up with a good result. The other thing about it is that it has a reverberation time of 22 seconds. It's absolute crystal. And when they opened the building, they got the Gewandhaus Orchestra, conducted by Kurt Masur, to play a piece of an opera. There was a moment of a single piano. It was just magic. What's the invention in it that has then since been exploited by, in this case, Glasbau Zähler? Not very easy, but this is the joint. There's laminated glass. And when a building is moving and the glass is hung, lots of things happen. I think if I go to the next one, you can see it here. This is a sheet of glass. It's over 3 meters long, about 1,800 wide. You have a fixed point, which is that one, fixed. You have this one, which is X and Y, so it's got a pin through it. And these two, sorry, that's X, sorry. And then these two have X and Y. The actual breathing of the shell goes up and down. And go back a bit. And these wonderful little arms coming off, these cast arms, they're like little springs. So the Z movement's taken up and down. And with the Fraunhofer Institute in Magdeburg, right at the beginning, we said to the client, that's an awful lot of glass to clean. It's about 4 hectares. You need a robot. So here came the robots. We have one either side, and they run around with their little hands going inside and outside these frog fingers. The Fraunhofer Institute, it was the first robot they made, are now the largest European robotics company, and they're a university. So that was actually a benefit of influencing a very simple idea: how do you clean glass? So I didn't finish the other invention. One little one here. When you've got a lot of movement and you've got something like silicon, what you can't afford to do is to have the movement where the waterproofing point is, where the stress is. So what we did was to make this elastomeric, well, it's a bit of silicon extrusion. That is bonded, so that's the one that takes the movement. This silicon here is the waterproofing addition, but it's not under any stress. And the nice thing about this is all these ones have got socks on, little legs, they're little socks, and you can see the movement through the socks. I put that up because the poetry you get out of a humble brick and doing something with bricks is an art that we seem to have lost a little bit of. And the beauty of the brick is that it relates to us as human beings. It's the size of our hand. We pick one up. It's no different from that. That is already a human connection. And the ability of some artists, architects, engineers, to manipulate bricks and produce very beautiful work is something I think fundamentally has to come back. And I think what's happening in architecture a little bit at the moment, we've seen in the last few years, is pattern making. Now, whether it's people like Herzog de Meuron or others, basically it's the people who invented fritting on glass for ovens. In your kitchen was the first ceramic fritting of glass in that little glass panel that you looked at the meat cooking. And they have a little funny edge. So from the domestic manufacturers of domestic appliances, we now have a whole world of printing glass. But the pattern making comes from the ease of software, laser cutters in the model shop, and it's very easy now to create patterns. What is important is to understand what those patterns represent, what they're saying, what they mean, and not simply, in my opinion, to decoration. I understand decoration, but I understand that patterns are the fundamental, if you like, ingredient of our universe. If you look at a beach of stones on a beach, the atomic structure of every stone is identical, but the outside is completely different. Every stone is individual, but the fundamental pattern is the same. So the story from Leipzig was an accidental, the youngsters in the practice of GMP saying, help. And because I don't actually have an ego problem, I don't have to go out to the world and say how clever I am, working with architects is quite good fun. The problem usually comes afterwards, when they discover you're an architect, and they want to advertise the fact that they're the architects, but they haven't really done the work. And that's where we end up with a jealousy of architects as the collective noun. I say it's a jealousy of architects. I don't know why. You don't get a jealousy of engineers. So helping people like Gmp with his pyramids, or Marg and others, has never been an issue for me. But it's often an issue for them, because I have a label. I'm like strawberry jam. Don't want strawberry jam to be known about. Yeah. So you get this kind of funny position of somebody who's technically competent, but happens to be trained as an architect. So if I say I'm an industrial designer or an engineer, which happened in Paris with Rice, Francis, and Ritchie, any three of us could become the poet, the industrial designer, the architect, or the engineer. And somehow it was a lot easier. And these are just examples. This is where we use 10 times the amount of material, but there are other reasons for doing that. So I've gone on quite a long time. So back to the research. What happened on this building was that all this copper was pre-patinated in a factory. The colors were all different, because that's what we wanted. They all arrived on site. Overnight, they were stolen. Copper's valuable. This is 20 years ago. It's East London. We should have known better, the contractor. It all disappeared overnight. So all the copper was made again and arrived brown. So it's all patinated on site, post-patinated. And its randomness is actually quite attractive, because it's almost like there are as many greens, tones of green in the building as there is in the grass, which is in the park next door. But it told me, get to understand copper better. What happens to it? When the oxides fall off onto the ground, what are they doing? And so we began a research program with what was then called Outokumpu, this company here, who became, I think, Luvata, and who've become something else, something like Anubis now. But I wanted to make a bluish, because blue is my favorite color. Actually, that's not true. It's 480 nanometers, if you want to be precise. That's the wavelength of the perfect blue for me. And it took 3 years of development to get this range of blues. It's now available, and it's simply called Some Architect Wanted It, I think. I can't remember what the range is called, something like that. And the great challenge there was, how do you stabilize the color? Now, we didn't really want to stabilize it, but you need to sell it at a particular condition. And it's the fill in the copper matrix, which is very difficult to deal with. And we tried calcium carbonate, we tried titanium dioxide, a whole raft of different compounds in order to stabilize this copper color, or this range of colors, against UV degradation. We wanted it to degrade, but not like in 3 weeks. And that was the problem at the beginning. So it's now available, and it would take about 30 years to go back to a greenish, but with hints of blue. The other one that we did research, now as I mentioned right at the beginning, we're at the molecular level, or the chemistry of materials. And one of the things that you will all know is that glass breaks. It's almost a Zen tradition that a glass, or a wine glass, only has a short existence on this planet. It's made, and one day it is going to break. Everybody knows that wine glass will break. It's not that dissimilar with buildings. We've got a lot of glass buildings, and I got interested when we were doing the Leipzig project, because we had some test failures on the hanging of the glass. I got quite worried, and on a flight back from Leipzig in the airline magazine, there was an article about Ormonces, which are ceramics, and the doping of ceramics to make them work better. So I started a project with Neville Greaves, who is a physicist and at the research centre in Warrington, the British Research Centre, into doping different types of glass with things like boron and other stuff, to see if we could stop it breaking, but leave all the wonderful crystalline qualities of glass. It's a bit like inventing the rubber tire that never wears out on a motor car. Now, the industry won't be very happy if you produce it. And we failed. We took 10 years of research. It was all done on a computer, what's called a synchrotron. And you can build the molecules, and you can heat them up, and you can quench them, chill them. So you can toughen the glass, you can break it, all on a computer. And that was about 15 years ago. So these techniques of beginning to understand how materials behave means that the Polytechnic di Milano maybe runs a program for its third-year architecture students, or architecture and engineering students, where they're not given a brick or some concrete to build a building. They're given a molecular structure to start with of a product, and to see how that behaves. And then comes the product, and then comes the building. And I think that is the story which appeared more or less 10, 20 years ago, about the whole thing of the cycling of materials on our planet and how we're going to use them at different stages as we transform them and transform them. Because, as we know, we have a bit of a few laws that seem to work for our planet, and one of them is called entropy. And eventually, all the energy goes in, it just gets weaker and weaker, but it's still all there. And it's the same, I think, with chemicals. So what is my philosophy? How would I kind of wrap it up in one diagram? It's this one. I leave you 2 seconds to read it. But it's about the ability to investigate properly, have a bit of poetry in your thinking, be aware of your sensuality and your environment and yourself, and bring in the other people that can, at the very high level, that can give you those dimensions that you don't quite understand. That, I think, diagram is what I would call the art of synthesis between kind of logic, practicality, and thought. Another one that Glasbau-Zehler now has, Wegeler now has as a patent, illegally, because we published this construction detail in 1987. We used it on this building, so it looks like a lake in the landscape. There's no metal outside. And Wegeler delivered it to Zehler to build it, and Wegeler patented it, even though we'd published in a big magazine with 30,000 distribution. But the Germans, like the Japanese, and to an extent the Americans, they patent first and see if you'll challenge. And China was going the same way until they realized that 2 companies in China made the same thing, or similar. Now that's quite recent for China, maybe 5 years ago. They couldn't deal with it because they didn't have the legal infrastructure in China to deal with the claim of one against the other on a patent. So the legal infrastructure of China has had to evolve in the last 5 years. But it's quite interesting how some countries will do a thorough search check on patents and others don't. And they wait for you to make a claim. And the other story of that building is the Gabion, which was an answer to Catherine Gustafsson's landscape. When we were standing on the site, it was pouring with rain, and I could see all the soil going down to the bottom of the hill. And I said, more or less, if you don't keep the soil, you won't be able to do a garden. And she said, what do we put in? Steel, concrete walls? And I said, no. You use the classic 7,000-year-old technique of gabion. The Egyptians used it in the Nile, largely with mud, hard mud and reeds. And this was the first time we'd ever used it in architecture. And they're freestanding cantilevers, 7 meters high. Marco mentioned to me just now that building a winery in California by some well-known architects. That's wallpaper. It's actually in a stiff cage and only has about 2 stones deep. It's just a veneer put on a building. These are actually holding the whole system up. They also provide the thermal mass for the greenhouse. And on the inside, there's one hose pipe, and it trickles water in the summer over the rocks, which are hot, and that gives evaporative cooling. And the wastewater ends up nurturing the lemon and orange trees that grow around the edge. There is no enclosure. It's a free space around the edge here, permanently. And they've only not used it for 1 day in the last 12 years, when it was too cold, not too hot, interestingly. So it actually has no maintenance. We don't even say clean the roof. Sorry, we don't even say clean the roof. The gabion itself, of course, is a home to birds, mice, insects, everything. And that changes naturally as well. So the copper and certain other materials like the corten you saw earlier, they all provide no maintenance buildings because no client wants to spend money on their building once it's built. It's a dream, but you can go a long way as a designer to alleviate the cost and the hassle problem. I'm going to go a bit quicker because I'm not sure where I am. Oh no, nearly the end. Sorry, we're nearly at the end. This was a bit of fun. Artist, physicist, software engineer, monument the French wanted to give Japan. It was to celebrate the 200th anniversary of the French Revolution, the 100th anniversary since the French gave the Statue of Liberty to the Americas. And it was that period of 1987 to 89, the revolution year, when Japan was not communicating with the rest of the world. It was quite wealthy, and the French thought it would be a good idea to give a communications monument. The Japanese wanted to buy Olivier Auber's software patent. They wanted to build everything. And despite President Mitterrand's pleas to the Prime Minister of Japan, please let us give you this as a gift, they said no. And the project was cancelled. So project communication never happened. But the structure was very radical. It was woven titanium wire structure as an ellipse in section, coated with carbon fiber mats, and then sealed. And the whole thing weighed 400 tons. It was 365 meters in diameter, so kind of 1.2 kilometer walk around the inside, which is where this live painting took place, the software painting. And you, with your keyboard, could join in this thing called the générateur poétique, or in this case, poiesis generator in English. And we levitated it off the ground with super magnets, potentially very dangerous, but with only 3 points of 15 square meters each, we could lift the 200-ton structure and the 200 tons of screen and cabling that lay inside and the people walking around it. Now, just a couple of other ones where you try and develop new applications of technologies that exist into the marketplace to bring quality and economy. We won a competition for pylons in France many years ago. And the first ones got built across the Rhone in 2000. Now, these are shell structures. They're just one piece of metal, they're steel, painted. We wanted to make them with explosion forming, which may be a technique familiar to some. But what you do is you dig a hole in the ground, you put some metal to keep the earth from falling in, fill it up with water, you make a female mold, like my hand, that way. You put it in the bottom, and you get somebody who's very, very good with explosives to put a charge in the middle of the water and use the water to send the shock waves into the metal that you've laid across the female mold. And your hand will come out the other side. That technique was developed in Russia probably about 1940. And they used it to make big axles for trucks, made in two halves, bolted together, all sorts of things with it. And we heard about it, and we thought, perfect for explosion forming these sections in two halves. Wonderful. EDF? No. Why? Sole supplier. What was interesting is, it was one explosive engineer was all you needed, because the rest is all very simple to do. But it's knowing what charge to put in, given the thickness of the metal, to get the shape you want. And a firm in Holland, Van Dam, developed, well, we said, would you like to bid on this project, because they're a good outfit, but only bid on explosion forming, not metal bashing, what we call metal forming, from the 19th century. Yes. Where do we find this out? They found the engineer 500 kilometers east of Kiev, the other side of the Ural Mountains, and they bought him, inverted commas, offered him a job, and they have the technique and they still use it a lot in Europe. The tragedy is these were made using 19th century technology when it could be made perfectly and quite quickly and economically. But they were quite nice. And you can climb up the inside. Can't see it there, can you? Yeah, just there. There's a little door up there. So you can climb up the inside, make a cup of tea or coffee, come out, do a bit of maintenance, come back in again. So it's the first pylons which are, in a sense, windproof, rainproof. Same shell structure. I won't dwell on this because I gather that it's used as a film at Milan Politecnico. But it does wave around a lot. So we have mass dampers inside to stop it waving around so it doesn't crack. But the interesting thing for us was getting the surface quality of bringing light down, not as a mirror, but as a soft line. And many years ago, a nun wrote to me from Ireland and said, one of our sisters is very ill and going to die. And she wondered if writing to her, which she's writing to me, whether I could send her a little storybook and something, a message before she went to heaven. I thought it was very sweet. For me, it was light coming from up there downwards, but for her, it was a beam of light taking her back from the earth back to heaven. So, quite interesting. This, again, engaging with industrial techniques to learn how to push some of these ideas forward. This is a logarithmic spiral, which you can recognize sort of in the wave, changing wave height as it goes out towards the outside. It's made of cast bronze, and again, it goes back to, like Rena Sophia, one CD was given for the CNC cutter, and it milled the perfect, in 7 sections, the perfect logarithmic spiral. So, in many ways, a lot of the imagery you see of distorted forms and spaces do challenge the industry to make. Some of them are absurd and rather silly. But others, when you understand the technology that they've got and how you can move the technology of the industry forward, then you can be intelligent about propositions which relate to your architecture and the making of it. But just to generate forms on a computer and hope somebody in that little story to somebody, the beatitude, the engineer, and hope for the best, is not the way I think architecture should go. And then finally at the bottom of this is a pattern. That's the bronze in the base that you walk on. There's a little gap as the spire goes into the ground and onto the granite. And that little gap is that wide. And there's a little drainage channel, because a lot of water comes down this spire. In that drainage channel, there's an inspection chamber, there's a room underneath. The most common object found? Anybody have a guess? Lipstick, yeah. Lipstick tops. Because this is the point in Dublin where you meet your lover. The same technology that made the spire are used to make a lover's seat. Now, it wasn't inspired by the lipstick, but it's just quite nice that it's very simply a rolled stainless steel and a piece of timber. And then, again, looking at, I just mentioned going back there, the wonderful word in English, and I don't know if it says it in Italian, but the inossidabile means stainless, not stain never. So remember, stainless steel does have a risk of staining, yeah, oxidizing. When you shot peen it, which you bombard it with stainless steel balls or wire, rolled up wire, that's the cheap version, you're actually penetrating the surface, and it's doing two things. It really is cleaning any impurities from the stainless steel surface. And the second thing it does, it's a bit like velvet, like those curtains. Well, I don't know, but sort of like those curtains. When you bombard it, you end up with multiple concave surfaces, small ones, on the diameter of the balls that are hitting it. And they, of course, overlap. The result is, at night, the spire of Dublin, not this bit, goes blacker than the sky. It's like velvet, because you've got multiple reflections of nothing. And it gets deeper. Quite remarkable, very nice. And again, this is about how do you take a technology that was emerging in theatre into an outdoor environment. And these are active acoustics back in 20 years ago. And they were used to produce improved quality in an indoor room. When I suggested doing this concert platform simply with a plate, a balanced plate, I asked the acoustician, would it make any difference if we gave it a shape to send the sound out? And he said, there's so much air out there, no matter what shape you gave the concert platform, it would make no difference to the listener, none. But he said the one thing you could do is make it fantastic if you're a performer on stage. So if you want an orchestra or a jazz band or a choir, you can give them the perfect acoustic on that stage. So you can feel that you're singing in a great cathedral or you're in a jazz club in a room. And that's the active acoustic system, which works by hanging a microphone, 3 microphones. The sound is picked up through a processor, microprocessor, straight out through speakers, which you can see here, and there's another row up there in the shell. The musician playing hears within a nanosecond the sound he's making. And that sound he's playing is the environment he wants to be in, the ideal concert hall or whatever. The fact that it's made of corten makes it cheap, relatively cheap, and no maintenance. Because the local authority had no money. So going forward, they didn't have much money to build it. They had no money going forward, so don't give them a bill. And then this is my example of if you understand the industry, understand materials, understand engineering and structure and environment, can design something, you're reasonably okay, and you can synthesize like an architect, and you understand the costs to make things, and what it costs industry to make, ship, put together, you know what labor rates are, you can design a building a third the cost of what a quantity surveyor will tell you. The Royal Shakespeare Company was told to build a 1,000-seat theatre with all the backup space, the bars and everything else, would cost £18 million. So let's call it 15 million euro. Quite cheap, relatively. I said we could do it for 5 million euro, or 6, to the board. But there was a condition. Leave us free to work with industry, don't let the government near us, and you'll have it in 12 months. And the client trusted us. Like the banksters took away trust, the ingredient for the architect is to have trust amongst every partner in the room. And it was all over in 12 months, and it cost £5.8 million. And it was made by the same team that did the concert platform. And they haven't got a maintenance problem with the building. It was supposed to be there for 5 years. It's now got planning permission to go permanent as a smaller theatre, rehearsal rooms, and a public exhibition of the wardrobe, all the kind of costumes of the Royal Shakespeare Company over the last 100 years. 60 years, sorry. People did not imagine you could ship in a giant container, huge container, 40 meters by 25 by 14 meters high, and drop it in the middle of the most conservative town in England. So it was actually quite good fun. Some of the things that we do in our studio, this is one example of many, is we invited a gilder in, somebody who gilds, just to understand material when it's very thin and how delicate it is to handle, what it does, what it doesn't do, whether it flies on its own, and so on. And ironically, about 3 months later, we got rung up by a charity, children's charity. Would we like to transform a British telephone box, the classic red telephone box, for charity? And it sold for about 5,000 euros. But it gave us all an education in gilding. And I'm coming right to the end now. This is a building that's now on site. It's the nearest thing to the present that I'm prepared to talk about. It's made of cast glass. It's a new technique, and it's slightly moving in a stiff way, and it has 2 rhythms, 2 pitches. Because in the middle of this building will be working computational neuroscientists, theoretical neuroscientists. On either end will be experimental neuroscientists who have a slightly lower wavelength of intelligence, in my opinion. Anyway, it's my sense of humor. The other side of the building moves with the environment of the wind and the wind wavelengths. So it's a moving building on one side and a stiff building representing the mind on the other. So in conclusion, we come back to the poetic. The thing that has appealed to me, and I mentioned it right at the beginning, is that a poet looks for, the romantic poet, looks for the meaning, the service, and the beauty. And after all this time doing architecture and designing, I've come to the conclusion that beauty is fundamentally non-linear. And it's the thing that we like nature for. Looking at the sky, different clouds, the sea, the pattern of light on the sea, leaves falling on the ground. All of those things are the things we all, as human beings, seem to enjoy. Somehow we don't get it into our buildings. And there are ways, which I've tried to show you, that we're beginning to do that. And it's actually working with nature to do it. So now you can buy the books. And there's a new book coming out in the spring, which is actually my story of just being an architect, as a human being and working, and some of the very naughty stories as well as the very sensible ones. So, grazie.